The number guessing game requires two players A and B. First, player A thinks of a random number between 1 and 100. Player B tries to guess the number that player A is thinking about. Whenever player B makes a guess, player A will tell player B whether the guess was less than, equal to, or greater than the number. Player B's goal is to guess the correct number using the minimum number of guesses. Here is an example of a game. Player B guesses the number 10, and player A says it's too low. Then player B guesses 25. Player A says it's still too low. Then player B guesses 44, and the player A says it's still too low. Player B guesses 50, and player A now says it's too high. Then player B guesses 49, which is still too high. Then player B guesses 48, and player A says that's correct. Player B needed 6 guesses to guess the correct number. What's the best strategy to guess the number as quickly as possible? One strategy is to guess 1, 2, 3, and so on until player B guesses the correct number. If player A was thinking of 1, only 1 guess is required. But if player A was thinking of 100, then 100 guesses are required. That is, the worst case performance of this strategy is 100 guesses. A better strategy is to first guess 10, then 20, and 30, and so on, until player A tells you that you guessed too high. Then decrease by 1 until we reach the correct number. For example, if the number was 57, then the guesses would be 10, 20, 30, 40, 50, 60, at which point the guess was too high, and then 59, 58, and finally 57. This strategy required 9 guesses. In the worst case, this strategy requires 19 guesses, if the number was 91. This is much lower than 100, so we're heading in the right direction. We were able to decrease the number of guesses by eliminating large groups of numbers with each guess. For example, by guessing 10 and learning that it is too low, we were able to eliminate numbers 1 through 9. If skipping 10 numbers per guess is a good strategy, then skipping 20 numbers per guess must be even better, right? Sort of. Suppose we guessed 20, 40, 60, then 80. If the number again was 57, then the guesses are 20, 40, 60, 59, 58, 57. That required only 6 guesses. But if the number was 41, this strategy would require 22 guesses, which is worse than the worst case for the previous strategy. But rather than giving up on this strategy, let's make a small tweak. Instead of decreasing by 1 until we hit the correct number, let's decrease by 10. Then, if we are too high, we decrease by 5. If we're too low, we increase by 5. Next, if we're too high, we decrease by 3. If we are too low, we increase by 3. Finally, we move up or down by 1 until we guess the correct number. Let's try this strategy on 41 again. First we guess 20, and then 40, and then 60, which is too high. Then we decrease by 10 to 50. This is still too high. Then we decrease by 5 to 45. And then we decrease by 3 to 42. Then we decrease by 1 to 41. And we hit the correct answer. We were able to guess 41 in 7 tries. Using this strategy, we can guess any number in 10 tries or less. This is significantly less than 19. We were able to decrease the number of guesses by eliminating larger groups of numbers in each guess. In the example above, When player B realized that the number is between 40 and 60, the next guess was 50. If 50 is too high, then we eliminated numbers 51 through 59 from consideration. If 50 is too low, then we eliminated 41 through 50 from consideration. Either way, we eliminated around 10 numbers. This pattern continues with the next guess, 45, which eliminates another 5 numbers, and so on. In contrast, if we decrease by 1, then the next guess is 59. If 59 is too high, then we have only eliminated one number, 59. We still have to consider numbers 41 to 58. Thus, our goal is to remove as many numbers from consideration as possible with every guess. The previous strategy came close, but the first guess is not optimal. If we guess 20 and we guess too low, then the number is between 21 and 100, or around 80 numbers. Instead, we should guess 50, which is the midpoint of 1 and 100. This allows us to eliminate half of the range, 1 through 50 or 51 through 100. We should continue to eliminate half of the remaining range with every guess. Thus, we increase or decrease by 25, then 12 or 13, then 6 or 7, and so forth. Let's try this out. Suppose the number was 57. Then our guesses are 50, which is too low, 75, which is too high, then back down to 62, which is too high, and down to 56, which is too low. Then we move up by 3 to 59, which is too high. Then we finally land on 57. 6 guesses were required. How many guesses are required in the worst case? If player A's number was 58, we would need 7 guesses, but we don't need more. Try a few different numbers, or every number between 1 and 100, to convince yourself that we don't need more than 7 guesses. To better understand why we only need 7 guesses, let's calculate the number of guesses needed if there were n possible numbers. In the sort comparison lesson, we showed that we can have a stack log of n times. Similarly, we need log of n guesses, since with each guess we are eliminating half of the possible numbers. For example, log of 100 is around 7, and log of 1000 is around 10. This means that we only need 3 more guesses to correctly guess a number between 1 and 1000.